Okay, good evening. Welcome to
Task number 10a.
test number 10a. Sorry for adjusting the camera a little bit there. So we're going to do a little project tonight, and I've actually asked your older brother to join you because we're going to talk about the square root of 2. So you are studying square roots.
Yeah.
Right, and this square roots introduce a new kind of number that you've probably seen before. I mean, we've talked about these things before, but now we're going to talk about it a little more carefully. So you're used to things like integers, which are what kind of numbers?
They're like 1, 2, 3, 4, 5, 6, 7, 8.
Yeah. And then what are some other kinds of integers?
Negative integers.
Yeah.
Negative. 0, 2.
And then there's another kind of number called rational numbers, which is the ratios of integers. A over b, where a and b are integers. So give me some examples of that.
1/2.
Like 5/8.
Okay, good.
2 over 1.
Oh, interesting. So 2 is actually
A rational number.
a rational number.
Yeah.
And now the question is square root of 2 a rational number? Can we write it in the form a over b, where a and b are integers? So that's what we're going to talk about today, and I'm going to show you 3 different proofs of this.
Okay.
Okay?
Cool.
Have you seen any of these proofs? Have you seen proofs that the square root of 2 is rational or not rational before?
Yeah.
But
Okay, so what's the answer going to be?
So it's not rational.
not rational.
Okay, so you already know it's not rational. Okay, that's fine. Do you have any thoughts about rational or irrational numbers before we dive in? Do you know any other irrational numbers?
Square root of 3.
Pi.
Square root of 3?
E.
Yeah.
Pi.
E, yeah. It's interesting. Pi and E are even more irrational, for lack of a better word. Because now, just for you, because you're studying a little bit about algebra, square root of 2 satisfies this equation, x squared minus 2 equals 0.
Yeah.
So there are some numbers that are not rational that you can write down equations for. But pi and e are even different than that. You can't write down any polynomials that have that describe pi and e. It's pretty neat.
Well, with integers, because like you could look at the square root of pi is x, and you could say x squared minus pi is 0.
Good point. Yeah, polynomials with integers. Good catch. All right, so hey, let's talk about the first proof of the square root of 2 being irrational. Okay.
Alright.